you know it's 3 secant pi.
One half. Excellent. All right. This is not how it's going to be given to you on the test. Given to you like this. Question number 1. Graph 3 secant of x. That's how it's going to start. So my question to you is, what's this 3 mean? Amplitude. All right. Now secant of x, you need to know what that is. Which trig functions have asymptotes?
Tangent,
Tangent,
cotangent,
cotangent. What causes it to have an asymptote? When you have a 0 in your denominator. It's undefined, right? What is another way of writing secant?
Cosine? What about cosine?
Or cosine, which is over x. So on a unit circle, on those coordinates, when do we have 0 for x? When is x 0 on that circle? Pi's right here. That'd be -1, 0. X is -1. What's another way of saying 90 to 70?
pi over 2 is 3 pi over 2.
This is 3 pi over 2. Or we're going to call it -pi over 2. I'll tell you why. I'll tell you why when we're done here. What's the period of all the functions? Tangent and cotangent is pi. Secant, cosecant, sine, and cosine are all 2 pi. So this is pi right here. We need another pi there. So I add pi to pi over 2, and that's where I get the 3 pi over 2. Think about it. -pi over 2 to pi over 2. That's the length of pi, isn't it? And another pi would get me back to 3 pi over 2. Alright, so these are all asymptotes. Everybody in here should be very good at the basic trig functions of how to graph them. I'm showing you how to do it. Hopefully we'll get through about 2 more. Repetition is your friend. Make sure you do this as much as possible. You should know what the trig functions look like before you even start. Which ones look like this? Which ones look like this? Which ones look like this? You should know which ones are which, so that you don't have to do a whole lot of plotting. If you don't know, then you're going to have to pick a lot of points on you and plug them into your trig function. As of right now, there will be no calculators on the test. You got to know your charts that I gave you. You got to be able to draw a circle and figure it out, just like what we did here. All right, so we have the period to be 2 pi. What's halfway in between pi over 2 and -pi over 2? 0. So let's plug 0 in. The secant of 0. Right here. What is this coordinate? 1, 0. So what is the secant at that point? The secant is 1 over the cosine, 1 over x. 1 over 1 is 1 times 3. If you know what the secant looks like, that's all you'd have to do. You can start drawing it at this point. Who knows what it looks like? Raise your hand. All right. What's halfway in between -pi over 2 and 0? What's halfway in between -pi over 2 and 0?
Pi over 4.
-pi over 4. Why is it -pi over 4 instead of 7 pi over 4? Because we are left of the y-axis at this point. 7 pi over 4 is way over here. okay? That's why we do it like this. All right, negative pi over 4. What is the x coordinate at that point? Everybody should have their hand up. It's the easiest question in this whole chapter. It's a 45-degree angle. What is the x and the y value?
Square root of 2 over 2.
Thank you. Pull your heads out of your butt and start trying. This is ridiculous. Asked you the simplest question in the whole chapter, and you can't tell me what it is. You're not doing what you should be doing. The square root of 2 over 2. That's the x value. It's positive. 1 over the square root of 2 over 2. That's the same thing as 1 times 2 over the radical 2. Rationalize the denominator. That's 2 radical 2 over 2. Or just radical 2. That's 1.4 times 3. What's 3 times 14? 42. 4.2. Yeah, I was agreeing with you. Here we go. And it's going to go up that way. Looks like a parabola, but parabolas keep going forever, left and right. These cannot pass these asymptotes. Looks like a parabola, but it's not. What's halfway in between pi over 2 and 3 pi over 2?
Pi. Pi.
Pi.
Where'd you plug the last one?
What?
Where'd you plug the last one?
Okay.
4.2.
I thought it couldn't go any higher than 3.
No. This is the local minimum at 3. Here you're going to have a local maximum. It will be negative 3. Okay? So at this point, based on what I've just told you, the local maximum at pi should be negative 3. So at pi, what's the x value? Negative 1. What's 1 over negative 1?
Negative 1.
What's negative 1 times 3?
Negative 3.
Thank you. And it goes like that. You should know what the secant function looks like. This is how the test is going to start for the graphing. Number 2 is going to look like this. This is what you have to do for step 2. You take this value and you set it equal to each of these x values that is in this graph. Because this will change, this will tell you where the first asymptote needs to be in this graph. Because 3 secant of something, if these two are equal, if these two are equal, then you have pi x equal to x. So whatever I put in for x here, for it to be equal, should be equal over here. So this is what you got to do if you don't understand what I'm saying. Set pi over x, or pi x, equal to any of these values. You've got to do them to all. So negative pi over 2 is the first one. What does x have to be? If you don't know, divide off pi. You get negative pi over 2 times 1 over pi. Negative 1/2. Okay, so that tells me in this graph that this asymptote, negative pi over 2, is going to be at negative 1/2 on this graph. Okay? The next one I did, I'm going to just use this one. The minimum was at 0. So pi times x equals 0. What's x have to be? 0. At 0. Okay, so when I plug 0 in, pi times 0 is 0. The secant of 0 is what? The secant at 0 is? One over x. 1 times 3. 3. Okay? That's not changed. Pi over 2 is the next one. Well, if I take the negative off here, that's the same thing, isn't it? So I'll get a positive 1/2. In a minute I'll tell you why it looks like this. Pi over x equals pi. Divide off the pi. X equals 1. At 1, I should get negative 3. Pi times 1 is pi. Secant at pi is what? Over negative 1. Negative 1 times 3 is negative 3. 3 pi over 2. So pi x equals 3 pi over 2. Divide off pi. X equals 3 over 2 pi times 1 over pi. 3/2. Why does it look skinnier?
Period changed?
Period changed. This is k. The period, and you should figure this out on the test, is 2 pi over k. K is pi. Period is 2. Negative 1/2 to 3/2 is 2. This is 6.28. 2 pi. So this is a third the size. Alright, now the last thing on the test would look like this. What's that going to do?
Shifted.
Shift to left by 1/2. Step 3. You take every x value you have here and subtract 1/2. So negative 1/2, I subtract a half. What does that give me?
Negative 1.
Negative 1. That's where that asymptote is shifted to. 0. 0 minus a half is negative 1/2. So negative 1/2, if I plug this in, I should get positive 3. 1/2 minus 1/2 is 0. So here is the second asymptote. At 1, subtract 1/2. I'll get 1/2. If I plug that in up here, I should get negative 3. 3/2 minus 1/2 is 2 over 2, or 1. That's that asymptote. You now have that graphed. So on the test, I'm not going to give that to you. It starts out like this. You got to show me that you know what the typical trig function looks like. Let's say you make a mistake over here. That doesn't mean you miss all of this. I'll mark on here what you missed. I'll take that into account, provided it, you obviously knew what you were doing. If it's obvious you didn't know what you're doing, you're not getting any credit. But if it looks like you knew what you're doing, you just made an error, some mathematical calculation, take that into account, and I'll make sure it's the same here. So you won't miss it here, and you won't miss it here. And you're not going to miss it 3 times. Okay, so that's how it's going to be. I'm going to do at least one more problem, hopefully 2 more. Okay? So what do we do? We graph the typical function. Step 2, you have to set this equal to every x value you're using in the graph. And that changes the period here. Step 3, all you're doing is either adding or subtracting to each of these x values. That's it. Got it? Let's do another one. Can I erase this? Okay, pick another problem now. Somebody. 45?
Y equals 2.
Hold on. Is that all right?
Did we just do that one?
No, we did 51.
Oh, that was 51 that we just did? Oh, I wrote 45 down. So that was 51, I guess. What's the one you're gonna do?
54.
And you were gonna do 45? What function is 45?
2 cosecant.
Cosecant, what's yours?
Same. It didn't matter.
This is
yeah.
3x plus 3.
And what's yours?
Pi x minus pi
Which one you want?
Shit.
Alright, 45. Read it.
Oh. 2 cosecant. Pi x minus
Just like that? Okay. Test is gonna look like this. This is the first one. You're looking. This is what you'll turn the page, this is what you're gonna see, except you won't see that. This will be the first thing you see, and a blank graph. That's it. Just say graph. Okay? So 2 cosecant of x. What's another way of writing cosecant? So whenever y is 0, I'm going to have an asymptote. Where's y 0? Here and here. Y is 0, y is 0. At 0 and pi. Cosecant has a period of 2 pi. There you go. Okay, so now I just need to plot some things. What's halfway in between 0 and pi?
Pi over 2.
Over 2. Let's plot pi over 2. Cosecant of pi over 2. What is the y value here?
1.
So the cosecant is
1.
1 times 2. If you don't know what this looks like, then you're going to have to do pi over 4 and 3 pi over 4. That's what the cosecant looks like. What's halfway between pi and 2 pi?
Pi over 4.
What's the y value there?
Negative 1.
And 1. What's the cosecant?
Negative 1.
Negative 1 times 2.
Negative 2.
Negative 2. Boom. That's 2 cosecant of x. Over 2, it's going to look like this. You're going to take whatever that is, set it equal to each of these x values. Pi x equals 0, so what's x equal? 0. That's not moved. Pi over 2. So pi x equals pi over 2. Divided by pi, multiplied by 1 over pi, you get 1/2. Good job. So 1/2. At 1/2, or we plug 1/2 in. Pi times 1/2 is pi over 2. The cosecant of pi over 2. Cosecant is 1 over y. That's 1. Times 2 is 2. Pi. So pi times x equals pi. What's x equal? 1. That's your other, if it's an asymptote there, it's going to be an asymptote here. We'll do the next one. Pi x equals 2 pi. Yeah, x equals 2. Halfway between those, 3 halves. And if we plug 3 halves in, that's 3 pi over 2. 3 pi over 2, the cosecant is going to be 1 over negative 1, which is negative 1, times 2 is negative 2. That would be problem number 2 of that problem. The period here, cosecant is 2 pi over k, k is pi. Period is 2, 0, 2. show you that it works. Step 3. It's gonna look like this. It's gonna look just like this. You cannot start the problem until you do something. What do you have to do?
Get the x on the outside of the.
You have to factor out the first value here. The coefficient has to be 1. So we gotta factor the pi out. That means you're dividing. Pi over 3 times 1 over pi. 1/3. Now you can start the problem. What's that tell you?
Shifts right, 1/3.
Shift to the right by 1/3. You're gonna add 1/3 to every x value you used in that graph. 0 plus 1/3 is 1/3. So 1/3, that's where the new asymptote is. 1/2 plus 1/3. Five, 6, go back to 4th grade. 1 plus 1/3. 4/3. 3/2 plus 1/3.
Seven thirds. Or 7/3. 6 or 7.
What?
Just don't listen.
How about common denominator? 9 plus 2 is 6. Okay, and then 2 plus 1/3. 7/3. Okay, at this value, what do we say it was?
We didn't do it. Positive.
Did I mess it up? No, that's 5, 6. I'm sorry, that was right. So 5, 6, if I put that in there and calculated it out, it would give me positive 2. This would give me negative 2. That's how you shift the cosine. Step 1, you have to graph the typical function with the amplitude if there's an amplitude there. Step 2, set this equal to each x value. That changes the period, shows you where the periods should be. Okay? Step 3, all you have to do is add or subtract these values after you get this to be a positive 1 coefficient. Add this to each of these x values. That's all you have to do. That's 3 graphs for one problem. But you guys obviously need some work. Okay? Time for one more. You want another one? Bailey, you want that other one? Can I erase these?
You need nothing.
Are we good? You understand how to do it now, or you want to see another problem? Yeah.
Brady's in the bathroom, he can't get to the house. Someone
Yeah,
takes
go ahead. Vito, you man the camera, please.
And -2 tangent parentheses 2x minus pi over 3.
Okay. Again, on the homework or on the test, it's going to look just like this. Tangent of x. The period of the tangent is just pi, not 2 pi. All right, asymptotes. Another way of writing tangent is y over x. So whenever x is 0, we have an asymptote. Where's x 0 at?
The y.
Yeah, here and here. negative pi over 2 and pi over 2. And the reason we go to negative pi over 2 is because the function, if we didn't, the function would look like that. It continues to the left of the x-axis here. This period is pi. Okay, so we already figured out these are asymptotes. At 0, tangent of 0, y over x, 0 over 1 is 0. So at the point there, if you want to make sure where these are at, then you plug in halfway in between here. This would be negative pi over 4. This would be pi over 4. You can do those if you need to. Pi over 4. You square root 2 over 2, square root 2 over 2, which is 1. This would be negative 1. That's the tangent of x. What does this do? If negative pi over 4 is y over x, that's negative 1. What's negative 1 times negative 2? Positive 2. It changed everything. So the amplitude stretches that curve out that's around the origin. What?
The line is stated.
Alright, so that's the basic function of tangent. We good? The inverted part of tangent. Yeah.
I'm so confused. What do you do with the y over x?
Y over x is what tangent is.
But like, what do you put into that?
These coordinates that you learned on the unit circle. The coordinate at negative pi over 4 is this coordinate. The y is the negative radical 2 over 2. The x is radical 2 over 2. That's negative 1. Something over itself.
Okay.
That's okay. I mean, that's what you're doing on all these. That's why you need to know the unit circle. And you know it really well. You gotta know those charts for the test. I'm not saying they're on the test. You need to know them very well. They may be on the test. Alright, so this is what you're doing. You're just plugging these. To get the coordinate, you plug these values in. Alright. The next thing you're gonna have is this. Graph negative 2 tangent of 2x. Set this equal to every x value you have on this graph. Negative pi over 2, so 2x equals negative pi over 2. That will tell you where the new asymptote is going to be. Divide by 2. X equals negative pi over 4. Negative pi over 4. 0. Plug 0 in, 2x equals 0. It's still 0. 2x equals pi over 2. That's just the opposite of this, which would be positive pi over 4. There's your graph. You already know what it looks like. All you have to do is draw it once you got this. Notice, what is the period here? Pi over 4 plus pi over 4. Pi over 4 plus pi over 4.
1/2.
Pi over 2. What's the period? Pi over k. Pi over 2. The next thing you have to do is shift. Number 3. You gotta factor out the 2. We factor out the 2, we divide. Pi over 3 divided by 2 is pi over 3 times 1/2 pi over 6. So I'm going to shift everything by pi over 6. I'm gonna take each of these x values and add pi over 6. What is negative pi over 4 plus pi over 6, fourth grade fractions? And 6th and 7th grade negatives. Oh, let's do 12. Negative pi over 12, which is very, very close to the y-axis. 0 plus pi over 6 is pi over 6. And pi over 4 plus pi over 6. Again, 12. Which is very close to pi over 2. Not quite there.
Good afternoon, Western High School. I hope you had a great Wednesday. Got a couple announcements for you at the end of the day here. First of all, we still have a few t-shirts to support Lexi left.
There it is.
The sizes are small and medium. They're being sold